Alright, so here begins the gravity problems. And I'm giving the first one. I'm going to use acceleration equation 1. If you guys remember, that's this one right here. So I'm going to come up with a problem, and I did, and it's going to use this equation. So let's do it. A rock is thrown straight up at 5 meters per second. How long will it take to come back to where it started? Well, at the very beginning, this rock went straight up. So it started at 5 meters per second, and that's definitely our starting speed. Remember, if anything is thrown, falls, or drops, we also know that, so let's write this down, VO is equal to 5 meters per second. We also know that A is equal to negative 9.8 meters per second squared. Because constantly gravity is going to try to pull this rock downward. Even on its way up, it's still going to try to pull it down, which will slow it down. Once it gets to the top, it'll start to speed it up downward. It kind of just keeps sucking it down like a magnet downwards, right? We know how gravity works. How long will it take to come back down? T is equal to question mark. And if you try to solve this, it's going to be impossible because there's no equation that has this stuff. You need a final velocity as well. But remember in my notes, by the way, my notes, hey, if you search Swanson Physics, I'm the top website. That's my website. You don't need to go here, but I do have the acceleration equation notes right here. So here we go. Note number, where is it? So when we throw an object up, its initial velocity is positive. That's why I put positive 5, because it threw it up, not down. But here, this is the important part right here. Rule number 8. It comes back at the same speed. If it comes back to the same spot, it comes back at the same speed. That's rule number 8. So if you throw something up like that, if you wait, it will come up here to a speed of 0 meters per second, but that's not the final speed. Not right now, anyway. If it asked me how high it went, then that would be the kind of final speed, because I wouldn't care about when it fell down. I wouldn't care, because they're asking me about stuff about up here. They're asking how long it would take to come back. So they're asking about if it came up and all the way back. Remember, the speed will be negative 5 meters per second for the final speed. So negative 5 meters per second for the final speed. And that's rule number 8. When you throw it up at one speed, it comes back at the same speed, but opposite. Obviously, it's heading down, right? Here's our equation. If you look, go ahead and pause the video and check it out if you want to look at it and compare these to these. See if there's another equation. I'm pretty sure there is not. The equation we're going to use is this one. And let's plug, it's not AT squared, is it? I don't think it is. No, I just made a mistake. I got used to putting that squared. Sorry about that. So let's plug everything in. Initial velocity is 5 plus negative 9.8 times t is equal to negative 5 for the final, right? Yeah. So there we go. It's all set up the number-wise. Let's put a negative 5 here, and then we'll minus 5 here, because this is a positive 5, so that'll get rid of it. And that'll make that a negative 10 is equal to negative 9.8, because a positive and a negative is a negative. So negative 9.8 times t. Let's divide by negative 9.8, and that'll get rid of it, but we have to divide by negative 9.8. And if you take a negative and a negative, you're going to get a positive answer. So I'm just going to do 10 divided by 9.8, and that's going to get me 1.02. So t is equal to 1.02 seconds. Positive, of course, because the negative and negative divided by negative is positive, which is good, because if you have negative time, you probably did something wrong. Okay? Alright, so that's it, folks, and try some practice problems. Actually, you know what? I'm going to do another lesson in a minute, and then you'll do some practice problems after that.